This video is about graphing square root and cube root functions. So the most basic square root function is the parent function y equals the square root of x. Very straightforward, there's no coefficient, nothing being added or subtracted. So to start out graphing any parent function, it's helpful to see a table of input and output values. And we're going to choose our input values wisely. Because we know we're going to have to take the square root of x, we're not going to use any negative values for x. This function is not defined for negative values. For x, only positive values. And we're going to choose the first 5 whole numbers that we can think of that have square roots. So I know 0 has a square root, as does 1, 4, 9, and 16. And I'm not going to go any higher than that. That's usually sufficient. And oftentimes 16 won't even fit on your graph. But we'd like to have at least 5 on our table. Then we're going to take the square root of each of these inputs to get our output. So the square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, square root of 16 is 4. And now we have a series of points that we can graph to see what shape this function makes on the graph. So we'll find point 0, 0, 1, 1. And it starts out looking almost linear, but then the next point is 4, 2. So our x has changed faster than our y. Our next point is 9, 3. 16, 4 is off the graph, so I'm not going to bother extending the graph. And I'm going to connect these. Notice I'm going to start from 0, 0, go through my points and make a smooth curve. And I am not going to cross through the point 0, 0. This function does not exist over here. And I don't want to see you continuing the graph this direction. It does not continue past 0, 0. And I don't want to see the graph turning around at the end. It does not come back down at all. It would continue rising slowly as it goes off to the right. So really be careful about the shape you're making with this function. If you're asked to state the domain and the range of your function, look at the function and we're going to say for the domain what x values are included in the function. And I see that the smallest x value I have is 0 on the graph of the function. And every other x value going towards infinity is going to be included. So I'm going to say that my domain is x is greater than or equal to 0. All of the values greater than or equal to 0. And then for my range, I'm looking at the y values. The lowest y value I have is also 0. And it is also going to increase slower, but it's going to increase up to infinity because this graph goes on forever. And eventually reach infinity, so our y values are also y is greater than or equal to 0. So state your domain and range by saying what x and y values are on your function. Now, what happens if I multiply or add or subtract different constants in this function? How does that change the graph? So if there is a number being multiplied by the square root, this creates what's called a stretch or a compression. A vertical stretch or a compression, which means that it'll either get stretched out vertically or it'll get compressed, which means shrunk vertically. If there is a number inside of the root being added or subtracted inside of the square root, this creates a horizontal translation. So that will slide our graph to the left and right. And if there is a number being added or subtracted outside of the square root sign, outside of the radical, this creates a vertical translation. You'll notice that in this formula, the h has a minus sign in front of it and the k has a plus sign in front of it. The minus in front of the h implies that you go the opposite direction of whatever is happening inside of the square root. If it says plus 4 inside, that means you're going to shift your values to the left. If it says minus inside, you'll shift your values to the right. So it's built into the formula to remind you to do the opposite direction. And if it's outside of the radical, formula has a plus k to remind you to go in the same direction as the sign that's out there. If it says plus 5, you will move it up 5. Okay, let's see this in action with numbers. So I have a square root function because that is a big 3 in front. This is not a cube root. This is a 3 being multiplied by a square root. It's a big normal size 3. That's going to be my vertical stretch. Because the number is greater than 1, it's getting stretched out. I'm going to include the 3 in the table. So when I make my table for my x and y values, I'm going to include the multiplication by 3 in my table. I am not going to include the plus 1 or the minus 2. The plus 1 I will deal with on the graph. I'm just going to write myself down that the plus 1 is a horizontal translation. Because it says plus 1, I'm going to go to the left 1 unit. And I think you should write this down as well. The minus 2 is a vertical translation. And because it says minus 2, I'm going to go down 2 units. And I'm going to do those on the graph. That's how I want you to do it as well. So I'm going to start by making my table, my x and y input table. Input, output. For my inputs, I'm going to use the same smart 5 values that I used on my first square root graph. The numbers that have square roots. And in my y column, I am not going to plug it into the entire function. I am just going to plug it into the square root and then multiply by 3. I'm going to deal with only multiplication on my table, the square root and the multiplication. So the square root of 0 is 0, and then I'm going to multiply that by 3, and it's 0. Square root of 1 is 1, multiply that by 3. Square root of 4 is 2, multiply that by 3. Square root of 9 is 3, multiply that by 3. And the square root of 16 is 4, multiply that by 3. These green y values are not the actual outputs for this function, but they're the outputs that I'm going to use to make it easier for me to graph. These points, the point 0, 0, is not actually on my graph, but I am going to start my pen at 0, 0, which would be here in the center, right? But I'm not going to put a point there. Start my pen there, and then I'm going to do my translations. It says horizontal translation to the left 1 unit and down 2 units. So I have hopped over to the left and down 2 and put my first point. Then go to the point 1, 3, which is not actually on this function. We find the point 1, 3, which would be here, and go to the left 1 and go down 2. That's the next point. So we're doing the table and then shifting manually on the graph. So I'm going to find 4, 6, shift it over to the left 1 and down 2 units. Find the point 9, 9, shift it over to the left 1 and down 2 units. And I'm going to run out of room to do the 6 and the 16 and the 12, so I'll just graph these 4 points. Again, start from your lowest point, but do not go through it. Try to make a smooth curve, and it takes a similar shape to the first square root function that we saw, but really stretched out. That's because of that multiplication by 3, that vertical stretch. To state the domain of this function, your lowest x value is a -1, right? I'm looking at this point right here, which I know is located at -1, -2. The lowest x value is -1, and then we go to the right from there. So our x values are all greater than or equal to -1. The lowest y value is a -2, and we go up from there. So our range is that y is greater than or equal to -2. This is a cube root function. So now we have a small, shrunken little 3 inside of our root. That tells us this is a third root function. And this is the most basic one. It's got nothing being multiplied by it, nothing being added, nothing being subtracted. So I'm going to start by making a basic input-output table, and I'm going to choose wisely. Again, I want to choose 5 numbers that have cube roots. And this time, I can include negative values. This function exists on the negative side and the positive side of the graph. We can do the cube root of a negative number. So I'm going to choose always for cube root functions, -8, -1, 0, 1, and 8. If you analyze those numbers, you'll see why I'm choosing them. I'm about to do the cube root of them, so I picked numbers that I know have cube roots that are whole numbers. The cube root of -8 is -2. The cube root of -1 is -1. Cube root of 0 is 0. Cube root of 1 is 1. Cube root of 8 is 2. Let's make that 0 look a little bit more like a 0. Okay, and now I'm ready to graph. There's No shifting that needs to be done. These points are going directly onto the graph. So I'm going to find -8, -2, -1, -1, 0, 0, 1, 1, 8, 2. You see these dots, and it can be a little bit hard to visualize how they're going to connect. I'm used to seeing this shape. I know what a cube root graph is supposed to look like. So trust me when I say we're going to try to connect them in this nice smooth curve. It does not make a straight line in the middle. It makes a nice curve shape, okay, like almost like an S shape. But it doesn't wiggle around quite as much as an S would. So you want to go nice curve to create the cube root shape. Remember, it does not drop down afterward. It would continue going up slowly. It would continue going up. Oops, move my graph out of the way. So since it would continue going up, we're not going to drop off at the end. Okay, keep it in the nice curve shape. For multiplication, adding, and subtracting, it's going to be the same idea as with a square root function. The number in front is going to create a stretch or a compression. A number being added or subtracted inside creates a horizontal translation. Number being added or subtracted out at the end creates a vertical translation. So let's see one. This should be a cube root. We're meant for that to be a cube root. So let's practice doing this as a cube root. The -2, we're going to deal with this in the table. This is actually going to flip our graph upside down, and it's going to stretch it out. The +3 that's in here creates a horizontal translation. Because it says +3, that means we are going to go to the left 3 units. And this -5 creates a vertical translation. And because it says -5, we're going to go down 5 units. And we start by making a table. So we're going to make a table for x and y, choosing our x values. Whoops, that does not have a cube root. Choosing our x values wisely. So we're choosing those numbers that have cube roots. And we're only going to deal with the multiplication and the root on our table. So the cube root of -8 is -2, and -2 times -2 is 4. The cube root of -1 is -1, times -2 is 2. 0 times -2 would be 0. Cube root of 1 is +1, so then when we multiply it, it's -2. Cube root of 8 is 2, so when we multiply it, it's -4. Again, these 5 points are not on the graph. We're going to start with these 5 points and then shift them. Take each one of them and shift it to the left 3 and down 5. We're going to find -8, 4, which would be here, but then we're going to shift it to the left 3, 1, 2, 3, and down 5. 1, 2, 3, 4, 5. And I end up being here. I'm not going to show that for all of the other ones. I'm just going to do it. I'm going to find -1, 2, shift it to the left 3 and down 1, 2, 3, 4, 5. I'm going to find the point 0, 0. Then shift that to the left 3 and down 5. Find the point 1, -2, shift it to the left 3, down 5. And then finally the point 8, -4, shift it to the left 3 and go down 5. Again, this is the S-shaped curve, but it's backwards because we made it negative. The whole thing flipped. So this time my curve looks like this. Try to make it as smooth as possible. And for all cube root functions, when we state the domain, you'll notice that the arrows go left and right forever. There is no such thing as a domain restriction for a cube root. So our domain is going to be all real numbers. The range for our cube root function, again, the y is going to go up forever and down forever. That's what those arrows indicate. Though it's increasing and decreasing slowly, it's still going to go up and down forever. Our y values are going to be all real numbers as well. So our domain and range are both all real numbers for cube root functions. And that is all.